Hello everyone. So today the problem which we will solve is the third problem of this contest. So let's read the problem statement. The problem says that minimum operations to make array non-decreasing. You are given an integer array nums of length n. In one operation, you may choose any subarray nums of L to R and increase each element in that subarray by x, where x is any positive integer, right? Return the minimum possible sum of the values x across all the operations required to make the array non-decreasing. An array is non-decreasing if nums of I is less than equal to nums of I plus 1 for all the values, right? So the subarray is contiguous non-empty sequence of elements within an array, right? So what do the problems say? That your nums of I, right, should be less than equal to nums of I plus 1 for every element, right? Until the very last element, right? So that means you can have an array 2, 2, 3, 3, 4, 6, 9, something like this, right? So two elements can be equal if they are consecutive, or that should be increasing, right? You can't have a decreasing array, right? Okay. So I hope the problem statement is clear. Now, not the problem statement. I hope this thing is at least clear to you. Right? Let me close these. So what are they saying? The problem says that you can add any possible element x to your subarray, right? So if your subarray is decreasing, right? Let's say this had a value 4 and this had a value 3, then you can pick up this subarray and add a value x to it, right? Now, first things first, you should understand something. The first thing is what would have happened if you have added a plus 2 or plus 1 here. You just need a plus 1 to make this array to its proper form. That is, you can have a 4 and have a 4 and you are good to go, right? At least this subarray is increasing, right? All right. So first thing you should note, I will take the test cases, don't worry for that. So first thing, what my intuition, see the contest is still running, right? And the first intuition while I solved this problem was what would have happened if I had a decreasing subarray, right? So in that case, I would love to pick up the window in which the elements are decreasing. I would love to pick the window. Let me write it. I would love to pick the window which is decreasing, right? What is the sense of picking the window which is decreasing, right? Let's say I had a value 4 over here, right? Or let's say 14 over here, and 3 at this place, 2 at this place, 5 at this place, 1 at this place. You tell me, if I want to increase the elements, this element should at least be 14. This should be, in order for the array to be increasing, this should also be at least 14. This should also be at least 14. At least 14, right? This should also be at least 14, right? So in my thought, these elements should be added plus 14 to all, right? But if you do that, there is a tricky case. At least you have understood that these elements should be 14 no matter what is the case, right? So ultimately you would want something or so or something related to this, right? Exactly not this, but something close to this, right? All right, I will come to this case again, right? Let's first take the test case, which is 3321, right? 3321. Now this doesn't bother you, this does bother you. You start from here. This, for this case, see the last value, last minimum last value which we had, was 3, and the value we need, right? Value we need is 3. We need at least 3 to break the curse, right? If in future you get a 3, then you will say, okay, I am at a good position, let me stop at this point, right? So to break the curse of increasing array, you need at least 3, right? Or greater than 3. 5 would also work, right? So you will say, okay, this subarray needs to be reformed. And how will we reform this? We will reform this by 3, 3, add 1 to this. You got a plus 1. While doing that, you saw, okay, this one also needs a plus 1, right? Why would I waste my plus 1 rupee in increasing only this? Why not increase this? right? So we will say, okay, I will do a plus 2 to this subarray, right? Plus 2 plus 1 to this subarray, right? That means it will become 3, this will become 2. And after that, I will do a plus 1 again on only this subarray, which will make it a plus 2 of total, right? I hope you understood how we did. First, we took up this subarray, we added just a plus 1 to whole subarray, and the subarray started looking like 3, 3. This became a 3 and this became a 2. After that, you picked up this subarray, you added a plus 1, and now your subarray became this, right? It became a plus 2, and now your subarray is 3, 3, 3, 3, and which is increasing in fact, right? Let's quickly look at the last case, right? 5, 1, 2, 3, and we will be good to go, right? 5, 1, 2, 3, if I'm not wrong, right? Okay, cool. So you have to make this element 5, right? At least this should also be 5 and this should be 5. So you will say, okay, I will pick up this array and add a plus 4 to these. First, listen to my thought, then we will conclude that what is the how we will go forward in this, right? I am saying you have to do a plus 4 up to this no matter what, right? So sorry, so what will happen, you will say, okay, I did a plus 5, I did a 5 here, I did a plus 4, it became a 5, right? If you do a plus 4 at this point, this becomes 6, and if you did a plus 4, this becomes a 7, right? Now look at this, is the subarray increasing? Definitely it is. So your answer is plus 4 to this test case, right? Okay. And if you look at the constraints is 1 in 5, right? That means that you have, so we need to write a solution which is big of n or n log n. Alright. So before jumping to the solution, I am bringing a beautiful test case for you, that is 10, 24, 1, 11, and 3, right? So because my first intuition broke down on this test case, so I have a clear logic why that happens. So you have a 10, you say I'm good to go. 24 increasing from this, very great. 1, here things starts to fall, right? What you will do, you will say, okay, this should be at least 24, right? So you will say, okay, 10, 24, let's make this 24, right? You will say, okay, if I make this 24, this should be also taken care of. This should also be made 24. And if it is so, this should be also made 24. And let's say there was 100 written over, right? This should not be made 24. This is good to go, right? So you will say, okay, till this point, I need to add at least some values to it, right? Okay, my greedy thought is, this is correct one, you have to listen to this, right? My greedy thought is simply make them 24, right? That's it, right? Okay, means add a plus 23 to that, right? Add a plus 23, at least one should be added at 23, right? So let's add plus 23. My greedy thought said this, let's see what happens. What would have happened if you had added a plus 23 to this? It would have become 24, which is very good to us, right? What would have happened if you have added 23 to this? This would have become 34, right? And what would have happened if you had 23 added to this? This would have become 26, right? Now, if you look at this subarray, this is sorted, but this again created a problem. And you will say, okay, add a plus 8 to it, right? Plus 8 to this. So array becomes 10, 24, 24, 34, and 34, which is very great for us, right? Okay. So now what I'm saying is, let me reset this canvas. I hope there's some problem. Okay. So the test case I remember still, no worries for that, right? Okay. Let me take this color. So 10, 24, 1, 11, and 3, right? Now what I'm trying to say is, if you saw this subarray and added a plus 23 to it, because we know that minimum value that you should have, right? And minimum value that you had, minimum value you should have, right? And minimum value you have, right? Which is 1. I'm not saying about across full subarray. I'm saying just the first one which you need to take care of, right? You needed 24 and 1, you had this. You needed to take care of these and add a plus 23 to yourself, right? This is at least thing, right? But if you go on doing that, right, you might end up in a big of n square solution, right? See, I'm taking the time because I want the intuition to be clear to you. I don't want just to want to give a solution and say, okay, you're good to go now, you can understand. No, see the intuition behind this, right? So what I said, let me first again write a test case. 10, 24, 11, 1, 11, 3, right? So if you have this pointer I, we will be using sliding window. Now how we will use a sliding window, understand this. If I was at this pointer, let's call it J, I came at this, I saw, okay, the condition that the array should be increasing fails at this point. I simply say, okay, starting from this point, run until you get something greater than equal to 24, yes, right? So you will say, okay, I will go to this point, I will go to this point, and I'm ending. Let's say there was 100 as well. You will say, okay, I will break at this point, right? Now, if you break at that point, what happens? Let's see that. If you do so, we saw the test case that 11 became 34 and 3 became 26, and there was still a gap, right? You thought of doing great, but you end up making one mistake on the right side. And if you again go on fixing these, you will run in a big of n square solution, as I said, because you want to be greedy, right? You want to be greedy, you want to pick a subarray which is not increasing, and you should make sure that these things also take care of it, right? So what you will say is, if you encounter a case where array of I is less than array of I plus 1, right? After entering the while after entering the window loop, after entering the window, what does this mean? See, the again I'm taking this test case because we are familiar with this now, right? You saw that this is our window, right? This was our window irrespective of, let's say 100 was also there, right? 100 is outside of this. So you will say that, okay, this is my window, and in my window I will check one thing. If my array is, if my element array of I, let's call this as array of j2, right? If my array of j2 is less than array of j2 minus 1, so if you are standing at this is j2, then j2 minus 1 is this, right? If that happens, then you know that I need to add some value to this, right? You need to add answer plus equal to 11 minus 3, because that in future you will have to add irrespective of whatever value you had, right? And why will this work? Why will this work? Let's have a proof of that as well, right? So let's say you said, okay, 10, 24, 1, 11, 3, right? In that case, you will say that, okay, I am adding 23 to these, right? See, you can't separately go and make this 23 and then think that your answer will be greedily minimum, right? That won't be the case. That won't be the greedily minimum value. And that is very obvious because a subarray of length 3 gets added 23 in only plus 23, whereas you would have to need to add this 23. So you would have added 23. Then you said, okay, let's say if this was the case, you thought that, okay, 3 is there, so I will add just 11, 23 till this point. I will try to make this 23, right? So what will happen is we will say, okay, plus 23 for this, right? Okay, so the sorry, I got disconnected, and again I'm shooting from the point which didn't got recorded. So what I was saying is, let's say you had 1, 11 and 3, and you thought, okay, I will add 23 to this, only 12 to this, and if you add only 12 to this subarray will only get added 12 as well, right? So now your array would become 24, left values are still there. This also becomes 23, 4, right? And if you add only a 12, because see, if you think of breaking a point in means you want only to add a 12, then on the right side only 12 will be added, right? Are you getting my point? So this will become 24, but this becomes only 15, right? uh, Sorry, not 12, 13, because to make it 24 and 13, so this becomes 16, right? So if you do so, are you seeing a pattern that the value still remains short, still short by the difference initially it actually had, right? So what we can say is we will have a sliding window, right? That will create a window which is wrong for us, right? After creating a sliding window, in that window we will check if my nums of j2, right, it is less than nums of j less than equal to, if it is less than, sorry, if it is less than nums of j2 minus 1, then that value should be added, right? Irrespective of whatever the means the difference is, you need to add it, because see, even if you can split it, you still have to add the difference to it, right? So what is my logic? Let's do a try run. 10, 24, 1, 11, 3, right? You got a case where it broke, you say okay, let's add 100 as well. So I will start from here, I will go till this point, and I will simply blindly add whatever the difference is. The difference is the value that should have been added is 1. Initially it had 24, so difference is 24 minus 1, 23. I will add 23 to all of them. Array becomes 10, 24, 1. And what more I should add? I should add, at this point I should add their difference, because nums of 3 means 3 is less than 11, right? So how much should I add? I should add in this subarray at least 8, right? So I will do that, right? So what I will say is, okay, plus, do a plus 8 at that as well. So now your subarray will look something like 10, 24, 24. In this subarray you added a 23, right, which made it 34. And after that, in this you added a plus 8, because this was failing initially, so it became 3 plus 8 plus 23, which is 34 as well. And now your array is increasing, right? I hope this made a sense to you, right? um, so let's see the solution for that, right? Let's see the code. So the code is pretty simple. While I is less than n, if nums of j, I is less than equal to nums of j, you break I to j to I and do I plus plus, right? Else your start becomes at I, j2 is I plus 1, right? You start at the very next index, right? And the minimum value we should have is nums of j, and the minimum value which we had was nums of I, right? Now what we will do is, while j2 is less than n and nums of j2 is less than minimum value that we should have, that is 24, right? In this case we had at least 24 we need to have, right? Else our window will keep increasing, right? We'll keep increasing that, right? Now we will check one more condition which we talked about. If nums of j2 is less than nums of j2 minus 1, then the add value will be whatever the difference was, right? Means if like 3 is, this should have been greater than this one, right? But if that is not the case and you are still in the window, then you will say okay, add 8 to this so that this comes to par with 11, right? I hope I am making sense to you, right? And you simply do a j2 plus plus, right? After this what you will say is, difference is the minimum value which you should have minus minimum value which we had, right? And plus the add value which we created, right? The array where like 3 and 11, right? That case you had an extra 8 to make this 11, so that the window doesn't get break, right? The window is still clear to you, right? And you simply move the pointers to the correct position, that is j becomes j2 minus 1 and I becomes j2, right? And you simply return the answer, right? Now this is a test case, which this is the whole problem statement. What is the time complexity for this? So you are simply running a big O of n. How is that so? See, you are traversing from left to right? And at any point if you figure out a case where you fail, you simply you create a window, right? And after creating your window, let's say you were initially standing at this point, you saw this is your window, you will simply jump out of this window. You won't again be checking in these. And how did you take care of not checking in those? You simply take care by saying okay, if my value is 3, here it is 11 and this is 3, I need to add a plus 8 initially so that I don't fail my test cases, right? So I hope the problem statement and the logic was clear to you. If you have any doubt in this, you can ask in comments. If you don't understand any part, please ask in the comments, right? I would love to help that. And thanks for watching. Please do subscribe this video. Thank you.